Today we are discussing about managing and removing base images. Previously we have discussed how to install Docker and creating Docker image, then running the Docker container and some of the commands. So you can go through my previous video to learn from the basic. Okay. Now managing and removing base images, we are going to start. Over time, a development machine accumulates unused images, stopped containers, and dangling layers. So there will be a lot of unused images and stopped containers and all. So the data will be high in the our Linux servers or Windows machines. So Docker provides commands to inspect, tag, and clean this up. So this we are going to clean up regularly, and also we can inspect the Docker images with the commands. So I will log into my EC2 machine where I have installed Docker. So I have installed Docker version 29.6.1. So here, if I check, there are a lot of Docker images available. So if I want to inspect one particular image, inspect is nothing but to get the complete information about a Docker image, we can use Docker inspect and the image name. So which image I want to go through it. So I want to go check Nginx latest. So it will give the details about the image in the JSON format. So you can see what are the labels it contains: maintainer, Nginx Docker maintainer, stop signal, currently what is the status of that image, and what are the ports enabled for that image, and when it is created, it's going to complete details. You can see image tag, then comment, Dockerfile, then created, when it is created, and configuration, export port, and what is the environment for this, and other environment variable like version, Nginx version, NGS version, release, package, and all. Then entry point, everything we can find out. So for every image, we can check it by using Docker inspect. This one will helpful when we want to check the particular image. Even in the Kubernetes also we use the inspect command to validate the particular pod or image to inspect. Inspect is nothing but troubleshooting purpose. We will check it. So all the details we can find it out about the image. So next is history. So if you want to know about history of the image, so Docker images. So if you want to know more history about particular image, then you can use Docker history. So this one you can see complete information, image ID created when it is created 5 days ago, 15 months ago, CMD, the commands and all. So if you take it any hello world latest, see it is 3 months ago created and created by this particular command, and what is the inside of it, and what is the size, everything we can find out inside that one. So Docker history. So using this one, we can get to know how old the image is and what exactly it is done and what is the commands used here. Everything you can see in the Docker image. Okay. Next is tagging and removing. So you can tag an image with a new name or version. So if, for example, you have a particular image and you want to change that Docker image name and tag. So that one you can do it by using the Docker tag command. So using Docker tag command, we can use whatever the name and version you want to change it, you can do it. So I'll do for Alpine Docker tag the image name. Then I want to provide DevOps slash node 18. So if I check Docker images, you can see here the image with a different name it is created. The data will be same in the both, but it is created with a different name. So node 18 alpha will be available, but again it will be present as well. DevOps node 18, the new name. So if you want to change the name of that particular image, then you can use to create by using tag. And if you want to remove a specific image, then as usual we always do Docker RMI complete we have to give along with the tag. Tag version everything we have to provide, then only it will get deleted. So Docker RMI hello world latest. So it is unable to delete because the container is using its the particular image is using by particular container. So for that one we have to use Docker RMI-F. So if you use RMI-F forcibly, it will delete and also the container also will get to deleted. Then now currently the container is not running. You can see here the container also deleted. Okay. Next is remove all unused images, containers and networks. So if you want to delete unused images, containers and networks, then you can use Docker system prune. If you want to only delete a particular image, uh, you want to delete an unused image, then you can use Docker image prune. Docker image. So I don't want to keep the all the images. So at that time, what we have to do? Docker images. I will check. Currently, these are the multiple images available. So I will delete all the images. This will remove all the dangling images. You can click on yes. If you check Docker images, so these are all used one only. That's why it is taking. If I check Docker ps-a, so running container not using. Still, these are all not deleted. Let me check once again. I will delete Docker images. Docker ps-a, Docker rm. To delete a container, we use Docker rm and container id. Only as of now, Nginx and Node.js demo 4.0 is using. So Docker image prone, removing all. Still not deleting. Why? Then if you use Docker system prune-a, so Docker system prune-a. So what it will do? It will completely aggressively, it will delete all the stopped containers, networks not used by at least one container, image without at least one container associated to them. Everything it's going to delete. No, not working. Okay, now it is linked. So I have given yes, that's why it was not working. When I use Y, just then it will work. So it is completely deleted all the data and you can see total reclaimed space 3.8 GB is it is released. Now if you check, there is no image, there is no containers. All of them it is deleted. But in the real time, you should be very careful while running a Docker system through -a. It is a very aggressive and it removes every image not used by a running container and also it will delete each and everything image You can see here, when you execute the command, all the stopped containers, if container is running, then it won't delete. All networks not used by at least one container, then image without at least one container, then all build cache. This kind of everything it will delete. If I give yes once again now, see, currently there is no image, there is no container. That's why it is not deleted anything. Okay. Always double check Docker ps-a first, so you don't lose a container you still need. If you need the container, you should start it, then you can run the command, then it won't delete it because it will be running. If the particular container is using a image, then the image also it won't delete. So if you want, I can show you once again. I will pull a new image with my repository. I have created a new website actually, even for myself and also for demo purpose. So if you can go here, Docker, this is the image. Docker full version is 1.0. So it is pulling. So this is my new image which I have created. So now if I check Docker images, there is a new image. I can run Docker run hyphen d hyphen p 808080, then hyphen name portfolio, then the image name you have to give. Am I correct? The command is correct, right? So now if I check Docker ps, it is running 8080. If I go here, this is my website. Even you can create it, but it will take time. It should be running. Okay, now it's not running. Let me check why it is not running. I'll go to my website. Docker run hyphen id 808080 we have to give. I'll stop container. Docker rm. So Docker yes, images. Docker run. So build is not required because I have already image created. Now I can use Docker run hyphen id hyphen d hyphen p image Docker ps hyphen a ps. See, this is my website I have created. So I have created and I made it as a Docker container. Now it's working fine. Now what we have to do is, so we are discussing about prune. So I'm going to run the command image prune. If I run the command image prune, it will ask, I will give y. It is not deleting because container using the image. That's why it won't delete. So if I stop the image, stop the container, Docker images, Docker stop. Now again I will run the command image prune. Again it is not declaring because the container is still using. If I run the command -a now, Docker prune, Docker system prune -a, it will check for the stopped containers because currently the container is stopped, so it will delete. Let's see. See, untagged this one and deleted the image. If you check Docker images, images is not available. Docker ps-a container also not available. So if the image is, if the container is not running, then it will delete the image as well, container as well. Only if it is running, then you can save. Otherwise, it will delete. So that's why always double check the Docker ps-a if you don't need any container which is in the stopped state. Next is pushing Docker Hub. So pushing to Docker Hub is very simple. We can use a Docker login command. So I will once again I will show you Docker login. Login is succeeded here because I already previously logged in. But when you want to log in, we have to use the command Docker login. Then username. So tech wonders. Password you have to provide. Error response from the server misbehaving. So Docker logout I will do. Login credential is removed. Docker login. So we can go to this particular URL and here just enter the code whichever given here. Once you give it, it will approve and you can log in to your Docker Hub account. Next is you have to tag the first image, whatever the image you have pulled, that one you have to tag it. So for example, currently I have Docker demo cd Docker demo. So here I have a Docker file. So I will use Docker build -t -name. So what I will do, my first image 1.0 dot. Docker build X requires one argument. So it is creating. The image will get created here. I will push to Docker Hub. So pushing Docker Hub, what it will do, the local Docker images we are going to push into Docker registry. It can be private and public. If you make it public, anybody can pull your images with just the name and tag. If you make it as a private, then they can't pull it. So in the real time on the organization level, we are going to make it as a private repository and we are going to store our all the Docker images with the different versions. So whenever we want to do the rollbacks, we are going to put for that particular previous versions of Docker image. Now it is created. To push it, just a Docker push. Before that, we have to set up a tag. So for that one, we have to use a Docker image, Docker tag, this particular. Next, username of your account you have to provide here, slash the name, the tag which you want to provide. So if you want to provide same name, then you can give the same name. Otherwise, you can change it. So I will just give same name here once again. Now it is tagged with the username because here I have used my account username. Now I am going to push it. Docker push complete name 1.0. So it will be pushed here. If you go and check here, Docker image is pushed here. You can see size 856. Everything it is done. This is the first image. Just now it is pushed. Like that we can push it. Once you push it, you can delete your image in local as well, but it will be present in the remote. That is Docker Hub. So if you want to pull it back, then you can use Docker pull. Same your username and image along with the tag. Image names follow the pattern registry slash username slash repository colon tag. This is the one which we are going to use. Registry is the registry name we are going to use. Here we are already used. TechWonders is the my repository, your repository name which I have taken. So you can go here, create a repository. If you want to create a new repository, you can directly create it and you can provide the details there. Next is when no registry host is given, Docker assume Docker Hub for a private registry. You had instead tag. It has myregistry.example.com slash username. So it's going to consider like this. If you don't provide any repository, so it will automatically take it and it will use your username and tag. Next is create your own images. So we have already created a image, but they once again I'm going to explain how you can create with a different Docker file. There are two common ways to create your own image. That is interactively customizing a container and committing it. Like we have already discussed about Docker commit. So you can use the Docker commit as well to make it your image as updated version. Otherwise, you can use a Docker file that describes the build product reproductively. And also we are going to use mainly this one. This section ties two approaches together with a second complete example. So we are going to use both together here, Docker commit and Docker file, and we are going to create a new image. So Docker image is read-only blueprint. We can't do anything. Only we can create a container. It is a read-only, and we can create multiple container with the image like container one, container two, container three. One image can start many independent containers. So with a single image, how we can use like in the EC2 instances with a single AMI machine image, we are going to create multiple containers. Like here as well, we can use a single Docker image, multiple containers. So this is an example, a Python Flask image we are going to create app.py. So I will create one more. Make directory Python. So I will copy this code. In app.py.
Mohan, can you ping that in chat?
Which one? Discord.
Yeah.
Okay. So I'm unable to copy again. Last time also we have faced same issue. I will do. So file name is app.py. Now again another code. Okay. Requirement.txt. This is the code which you have to use. So if you are able to open it directly, we can use VI and add this code. But currently I'm facing issue with the VI. So that's why I'm using the different approach. Requirement.txt. Now another one is Dockerfile. So Dockerfile, I will explain what and all stages we have used here. Echo content, Dockerfile. Now I have created. Okay. So inside Python, I should have created. I will copy them, move them, move requirement to inside Python, move Dockerfile inside Python, app.py. Okay. App.py requirement.txt, then Dockerfile. These three I have created. Now I'll go inside
Can you share
Python.
those two? Mohan, pause
Huh?
it. Can you share those two?
Sorry, which one? Okay, that one I will share. So requirement txt is a single line code. You can check it. Flask and Dockerfile is this one. I will share you. You can check it. And now I'm going to run Dockerfile. I'm going to create a Dockerfile. Python is not installed. Directly I'm going to use a Dockerfile by using Docker build. Before that, I will check whether the code is correct or not inside. Okay. App equal to Flask. Score name. Hello. Hello from my own custom image. Return. Okay. We are good to go. Now, vim Dockerfile. So what is Dockerfile? The content it shows here. So mainly from. So we are going to use the from as mainly for the base image. So base image we have used for a Python here. Python 3.1 Slim. Why Slim used? To make it the Docker image should be lightweight. That's why we have used a Slim as a version of Docker Python image. So it's going to use a work directory, that is a slash app, as a default work directory, and we are going to copy the requirement.txt into this particular app. So work directory slash app means all the commands it's going to run inside that particular app directory only. That's why given as a dot. Okay. Next, I think some command here. CMD Python. Yeah, this one we have to make it the double quote. Okay. Next is run pip install no cache directory. So it is going to install the requirements by using requirement.txt file. So in the requirement.txt file, we have mentioned as a Flask. So it will install the Flask as per the requirement.txt file. And next is the expose. It's going to expose the 5000 code. And the last command is Python. So it will run the Python first, then app py. Both the commands it's going to run it. It will execute it. So once it is executed, the container, the application will run. Let's see now. Cat Dockerfile. Okay, it looks good. Now what command we have to execute? Docker build command we have to execute with the image. Docker build -t. The name we can provide Flask demo 1.0. Oh, Docker build -t Flask demo 1.0, and dot we have to give because the Docker file is existing here only. So it will build a Docker image for the Python application. So this is how you can do. Now if you check Docker images, see the Flask demo image is created. Flask image 1.0. In which one I have given here Flask demo 1.0. So it is created Flask demo 1.0 image, and if you go and run this particular command docker run -d-p, as we know already, docker run to create a container with the existing image. We do docker run d detach mode and -p for port mapping 5000 name. So name you can give what exactly name which you require for the for application name Flask app, then image. So this is the image. So Docker container is created. It is running now. But this one, I think, half baked. We can delete it. 14 minutes ago, it is created. npm start. Okay, first image it is not Flask. I confused. So now Docker image is running. Docker container is also running. So if I go here to my account and copy the public IP 5000, it won't work. I know, as we already know the same issues which we face regularly. We have to go to security groups. In the security group, we have to enable the port. You might think like every time, why should we change the port? We can enable all the ports, but that is a not good practice. We have to make sure whatever the port is required, based on that, we have to select only my IP and we have to enable that port. But for practicing purpose, I am using all the IPs I'm providing 5000 port. Save rules. Now if I execute 5000, allow from my own image. So custom image is created here. And if you change any changes inside that one, again you can create by using Docker commit. Let me show you that. So if you go inside Docker exec hyphen it container name dash. So inside this one you can see the files. It will be cd So this is the written image which it is showing. So if I want to change it, app.py, okay. No, we are unable to change anything. Normally, if you want to change it, then you can go here and we are going to change the complete whatever the changes required, and then after that we are going to use a Docker commit. So it will do the changes, and again with a new version we can create it by using Docker commit. So I did that one we have already discussed. So now let's go to creating a own Docker files. So till now I have just explained how we can use Docker files. So Docker file mainly support a specific set of instructions. It will be having the different commands. In the previous Docker file, we have just discussed few commands in Docker file. So here you can see 1, 2, 3, 4, 5, 6, 7. Only 7 commands we have used here, but there are many Docker commands we have to use inside Docker files. Understanding each one lets you write clear, efficient, and secure your images. So if you know about the commands, then only you can write what exactly commands we can use inside the Docker file. So first thing is from this is the first line of a Docker file. Every time you use, and it will base image to build from. So you want to build a particular image. For example, if you want to build your application for Nginx, then you use Nginx base image. If you want to build your image for Python, then you use Python base image. So you can take it from the Docker Hub. Next is work directory. It will sets the working directory inside image. So inside the image, you can see here where I have set as a working directory here /app. So when you do this one, by default, when you log into the system or log into the container, it will automatically go to the /app only. That is a home directory, and there only it's going to run all the commands when we run the container. And copy or add. So till now we have used the copy command. It will copy the file from host into the image. So it will copy all the files whatever required. It is we are going to mention here. So requirement.txt, it will copy this particular file inside the /app. That is this one. So we use whatever the files, main files, before going to run the container. Then that particular file we mention here. Copy, and we will provide the path if required. If the same path, then we use dot. Then next is run command. It will execute a command at build time. So at the building time, it's going to execute the command like install package kind of. So you can see here run. So pip install -r requirement. So before going to run our application, we have to execute this command to install the requirements of this particular project, then it will run it by using a run command. That is a run command here we use in the Docker file. Next is env. It will set the environment variable. So if you want to set any environment variable, then we use env. Currently, I have not used in my Docker file. Then arg defines a build time variable. So build time variable, we are going to set it up for that Docker file. Next, expose documents which port the container listens on. So the port which you want to particular port which you want to set it up, then we use expose command, port enabling purpose. So here we have used port expose 5000, so it will enable the 5000. Only the particular port we can run the application. If you use any other port, we can't run it. That is depends upon the application. For Python we have used 5000, and for Nginx and all we use 80 port. If you use Tomcat 8080, like that we are going to use. Next is volume. It's going to declare a mount point for a persistent data purpose we use, where we use in the Docker volumes. Then user, if you want to set the user, the container runs as. So for example, you want to set the container as a different user, then we are going to use user. Next is cmd default command run when the container starts. So when the container is start, this command is going to by default it will start because to run the application. If, for example, you want to run the Java application, then we use Java commands. Then you want to run Node.js, then we use npm install. These kind of commands we are going to use with a cmd. That is a default arguments which we use. Next is entry point. It will be configures the container as fixed executable. So fixed executable purpose we use entry point. These are the main commands which we use with the Docker file. Let's see further example. So from node, this is the Docker file I have given below. From node, we are going to provide Alpine. As I mentioned, for the lightweight image purpose, we use Alpine, and label maintainer equal to DevOps. So we have used a label as a command here. Maintainer equal to DevOps at team at the rate example.com. So maintainer for that particular image we have set up by using label. Then work directory, that is for we have set the default directory for the application /app. Next is copy package start.json. So whatever the package file, it can be package or application or package underscore 1.0 or package underscore app.json. Any files it is there, we are going to copy into this particular app directory. Then run npm ci omit equal to dev. So this command we are going to run for the before running the application we use, that is copy dependency manifests first better layout caching. So main all these we are going to use it before going to start the application. We use these commands. Now copy the rest of the source code. So once the one main file we have to copy it, and rest of the code we are going to copy it by using copy dot dot we provide. So all the data. So one is first data dot is nothing but complete data, you call it. In the git we use git add dot, so it will take all the data. The second data means in the current directory we are going to copy the files. Next env node. So this one environment variable we are setting node env equal to production. So in the real time we will be having different environments, dev environment, production environment, staging. So we are setting the variables as a production here. Then exposing 3000. So exposing the application to 3000 port. Next is cmd node app.js. Like this we can find it out. Let's see whether it will work or not. Even I am not sure. We'll run it. I'll go to here. So from node alpine, okay, everything is looks good. Echo. What I will do, I'll directly run here echo code Dockerfile. Now if you check vim Dockerfile, make sure everything looks good before running the Dockerfile, because it will throw the error even something is missing or some spelling mistakes, code sensitive, everything will be there. So I have done now. So all these commands should be always in the capital letter only, from label, work directory, copy, run, copy, env, expose, everything. Now I am going to run it. Docker build hyphen t. So it is building a new image. I have given as a node hyphen new 1.0. So Docker file, something it is showing. NPM error, a complete log of this run can be found out here. Clean install a project. This particular is now copy the rest of the code, source code. So it is throwing some error. You can see the logs here. Cat thing is there. Once again, I will try to run Docker images. So this particular command is throwing error. npm CA command itself is not working. Missing file copy. So package log JSON. Okay, here why it is not working is I don't have the source code. So we have to use again. We have to create a new source code and we have to set up. So I'm not continuing with this particular Docker file. We have already discussed the Docker file, but it is contain more commands with we can use it. Okay, you can practice it, but this one we need a source code. We can get from source code. If the source code is available, then only we can create a image with a Docker file. See, for example, this is my application. I have the source code like index.html file, then only I can run the Docker file. Otherwise, I can't run the Docker file. Here it is mentioned HTML file, then that should be present. Here it is mentioned the Docker file mentioned as a package.json file. So that should be present. Otherwise, it won't work. Okay. That's why I have executed to show whether it will work or not. Without source code, we can't run the Docker file. Make sure it should be present. Next is CMD versus entry point. So this is very important in the interview purpose as well, in the real time as well, because in the interview you will get the question as what is CMD, what is entry point in Docker file. So CMD provides a default arguments that can be fully overridden at Docker runtime. But entry point fixes the executable and any CMD becomes its default argument. So if you use a CMD here, app.js, it will be default argument, but it can be override while running the Docker run. We can change that particular commands. But when you use the entry point node, this one you can't override it. It will be fixed executable. At the runtime, it's going to execute by default. Here you can see CMD from the easily overridden. CMD will be npm start, and while running Docker run my image echo hi. So it will replace the CMD entirely. So echo hi is going to run it instead of npm start if you use CMD. But when you use entry point node CMD app.js, then Docker run my image others.js. So it's going to run the node others. First, it will run the node along with this particular file name. We can't app.js instead of app.js, it's going to run others.js. So this will replace, but this you can't replace. That is the main difference. Entry point is a fixed executable arguments we are going to provide. You can't replace them, but CMD is a default argument which you can replace while running the run command. That's it. Next is Docker ignore. Just like .git ignore, which we use with at GitHub, the Docker ignore files will be exclude files from the build context, keeping build fast and image small. So if you want to do any like you want to ignore something, some of the files, then you can create a Docker ignore inside the project. So if you go here, here you can create a file called vim dot docker ignore, and here you mention whatever the file you want to ignore, some files, or you want to ignore all the text files, you can give the slash star dot star txt, or if you want to ignore some anything, any credentials, then you can mention as a credentials files. This kind of you can mention it. So it what it will do, it's going to ignore that particular files. Somewhere I have written docker dot ignore. Okay, it is not there. Fine. So inside that one, you can just mention the file name or extension, whatever you want to ignore it. Then you can use Docker ignore. Same like Git ignore we use. Next is Docker events. So Docker events, like the Docker neighbor emits real-time stream of events. Whenever something happens, it's going to create a events. That is a Docker event. A container is created, started, stopped, or removed. Anything it can be. Like if you know, event is nothing but something is happening. Action is working there. That is called event. Every event is calculated here, like image pulling, pushing, deleting, creating, pause, resume, stop, start, anything. A network is connected also, it's going to calculate as Docker event. The Docker events command, it's going to let you watch this stream live, extremely useful for debugging and building automation that reacts to the container lifestyle stages. So when you use a Docker event, it will be showing the real time what is exactly happening, and it will be very helpful for the debugging and troubleshooting purpose we use. So Docker daemon container create container. So I have given the examples of Docker events. You can check it by using. Let me show you Docker events. So when you use the Docker events, watch all the events live. So this will be running in the terminal, and in another terminal we are going to run these particular commands. Let me show you. So I will open in the new terminal. So I will log in to same instance. So currently it is not showing anything. So I will log into the system and I am going to run the command Docker images. It won't create anything. And Docker PS. Currently this one is running. What I am going to do, Docker stop container ID. So you can Docker events, the container kill, it is happening, flask app. So all the details it will be showing. See, now it is stopped. Now again what I will do, Docker start. Same image, same container. I am going to start it. So here it is showing image flash demo, it is stopped. Now again it will create as container start. Here you can see container start. Like that it will be showing. So if I want to delete a image, so I will delete this particular image. Docker RMI 1.0. Let's see image untag. So all this will be listing in the Docker events. So when you run the Docker events, it will display all the events happening in the backend. That is mainly real time live events which we can see it. Okay. You will see a stream like container create, start, container die, stop, everything it will be display. Filtering events. So if you want to filter the events, only show container related events, then we use Docker events filter type equal to container. So you can use this one. Now I'm going to run in different one. Here, what I will do, images, right? Docker images. So Docker RMI. So I don't want these images, so I will delete again. This one I will delete 1.0. So it won't show here if you come. So it is deleted, but it won't show because I have given as a type equal to container. Same like that. If I use a particular one, only events for one specific container. For example, this is a container, then it won't show for any other containers. And if you use a certain time, since so if you give only that particular time, it will show the events. That is about Docker events. Next is Docker networking. So Docker networking is very important. So let me show you Docker networking with a more explanation. So networking allows container to communicate with each other and with a host system. Containers run isolated from the host system and need a way to communicate with each other. So mainly, container, one container to another container, how they can communicate. So that is the main purpose of Docker networking. We have different type of networkings. By default, Docker provides two network drivers for you, the bridge and the overlay drivers. So if you use Docker network ls, you can see bridge, host, none. These are the default we have. Scope will be local and driver will be bridge, host, null. So I think these are the default will be there. Bridge will be default, host, none and overlay used in Docker Swarm for multi-host networking. We are not going to discuss much on that, but mainly we have you are going to get the question as well in real time. What are the different type of Docker networking? You can mention Docker bridge, host, none and overlay. So it will display like this. So bridge networking will be the default network mode in Docker. It creates private network between the host and containers, allowing containers to communicate with each other and with the host system. So it will allow containers to communicate with each other and with the host system also. It's going to communicate. You can see here host, container, Docker, it will be there. So if you want to secure your containers and isolate them for default bridge network, you can also create your own bridge network by using this is the command. So if you go here, Docker network create -d bridge is the name of your networking. So this is the name bridge name I'm using. I'm creating a new network as my custom. So if I check it, Docker network ls. So you can see here my bridge has a driver will be same bridge and the name of your network will be different as you created. If you list the Docker networks, you will see that particular network, and this network can be attached to the containers when you run these containers. So while running the containers, you can run this particular container, and this way you can run multiple containers on a single host platform where one container is attached to the default network and other is attached to different network. So different networks will be there for different containers you can use. These containers are completely isolated with their private network and cannot talk to each other. So when you use this kind of, so it will be different one. This one will be different network and this one will be different network, and both are isolated. We can't communicate. However, you can at one any point of time attach first container to my bridge network and enable communication. So if you want to enable the communication, then you can connect the by using Docker network connect and this particular whatever it is there. So you can see here web application, the you can call it web container. So this one is there in the Docker and the db is there in the my bridge. So if you want to communicate both, then this one should be connect with my bridge by using this command, then it will be enable the communication between these two containers. That is called Docker bridge networking. So the command, if you want, let me show. While running the container, you can use it. Let me show you. Docker ps Docker image. So currently one image is there. So that's why I will delete the container which is already existing. Now I will do Docker network ls Docker run -d network is net. Then my bridge is a network name name. So you can give flask app. Sorry, flask. So it is created. You can see Docker run -d. It is created with a new bridge, and you can see like that. But here we have to use a multiple containers to check that one. So if I check Docker ps, this is the one it is created. So currently I am not creating multiple containers to show, but these are the commands which we use to connect between networks, and the DB and application we are going to use. Currently I don't have database, so I am not showing. So these command we should know: Docker network connect and Docker network bridge. So if you want to connect your different to here, so for example, you can use Docker bridge network. Instead of my bridge, I will use bridge network here. So it will change to bridge. No such container web. Okay. Flask. So what is the name of my app? Flask. Okay, Flask I have given. So the bridge network status will be changed here. So if you check Docker logs, if an app, this is development server, do not use production deployment. Docker logs, it is done, it is running now. Okay, so you can change, you can create a particular network, then we use a Docker network create, and to set up the your container with the network, then we use Docker run along with the network name. Then if you want to connect to the different network, then we use Docker network connect. These commands we should know. Next is host networking. So host networking, overlay networking is a different one. Mainly we use a bridge network, we should know as a default. The host network is, it will allow the containers to share the host system network stack, providing direct access to the host system's network. So host system network, we are going to use the direct access by using host networking. So for that one, we can create by using Docker run hyphen network equal to host. So then image name and command we are going to provide. So how to run a particular Docker container with a host network? We can use this one. Same like other command which we have used. Here we use network equal to host. There we use hyphen net equal to bridge. Then image name we are going to provide as usual. So keeping in mind that when you use a host network, the container is less isolated from the host system. That's why we always avoid the host as a networking and has access to all of the host network resources. This can be a security risk. So use the more host network with caution. So for the database, we always avoid the host networking. We always use a bridge network. Additionally, not all Docker image and combination are compatible with the host network. So it's important to check the image documentation or run the image with a hyphen network equal to bridge the default network mode first to see if there are any compatibility issues. So we always prefer only bridge network. That's why I'm not explaining much about host networking, but you should know about the difference between host network and the bridge network. Next is overlay networking. This mode enables communication between containers across the multiple Docker host machines, allowing containers to be connected into a single network even when they are running in the different host. Even the particular container in the different host, nothing but different Linux servers you can consider. That time also you can connect by using overlay networking. Those are the different networking concept which we should know as a DevOps engineer in the Docker. So I have given same in the notes as well. You can go through it. Next is Dockerfile for user. By default, process inside a container run as a root. So this is a convenient but risky. But if an attacker breaks out of the application, it's going to root privilege inside the container. That's why it will affect the issue for the Docker container. So the user instructs lets you create a non-user, non-root user and switch to that particular user in your Docker file. Following the principles of least privilege, you can see here. So after copy command in the Docker file, we use add group, -s, app group and add user. So we are going to dedicate a non-root user for the group and we are going to set up the different user. So different user means when you log into that particular container, Docker ps, Docker exec -it, fast bash. So you can see here root user. But instead of that, we can use a new user by adding this particular command run add group app group as a name as a app group and add username whatever the username and adding to that particular group. So then after that, ch1 changing owner recursively for the app user, that is a username and a group name for this particular folder. User app user. So it's going to switch to that particular non-root user. Then it will run the command cmd node app.js. So this is how we can use the particular user we can set up for that particular Docker file to make it as a secure. So let me show you once again. Ext. So here my Docker file, vim Docker file, currently from label copy run is there, right? So I'm going to cd docker demo vim Docker file. After copy package.json, I'm going to here I will run add group command run. By default we have to use a run because we are running the commands. Then add group -s DevOps I will give, and add user -s TechWonders as a username I have given, and then adding that user to group DevOps. Like this we have to provide. Then we have to run the command again, another run command by using run ch1 recursively TechWonders is a user and DevOps is a group for /app. Like this we have to provide. Then again user, we have to run the command user app user. So switching the user to particular user. Here my username is TechWonders. Now done. Now I'm going to save it. So I will run as docker build -t -name node user 2.0. It will create. So now if I check docker images, node user 2.0 created, docker run -d -p, you can see here docker run -d -p, name secure container, whatever the name we can provide here. Port I will give first port 3000 name secure app. Then we have to provide the image name. So it is created docker ps. This one is created. Now I am going to insert that one docker exec -it secure app bash. Docker exec name secure app. Who am I? So it will display here itself going instead of going inside. So it is displaying as a user, different user it is. Like that we can see. Actually, if I go inside, it will be better, but it is not working. SH. Yeah. Who am I? So you can see here, the user is who am I. If you use who am I, it will show the username with which user you have logged in. Like that, you can set up the particular user for your application instead of using root user. Got it? So why this matters? Limits the damage an attacker can do if the application is compromised. So if the application is compromised, it will be the limit will be very the damage will be very limited. If you use a root user, it will be having all the access for that particular user, and the application will be too much damaged, and the data will be lost. Many container security scanners flags images that run as a root. So if you run as a root, then the security scanners, when we use the Docker scanning, then it will affect the vulnerabilities and the issues with the security scanning report. Some Kubernetes cluster enforce non-root containers by policy. By policy, we are going to use the some Kubernetes clusters enforced by the policy with the container policy which we call. So that's why we use non-root user with the Docker images. Docker link. So before user-defined network existed, Docker offered the link flag to connect two containers and let one reach the other by name. So if you want to reach one by another one with a name, then we use Docker link. It's a legacy feature that still works, but it is not officially deprecated. So custom bridge networks are the modern replacement and should be used for all new work. So Docker link is same as networking, but it is a old one. Now latest one is Docker Bridge network, which we use to connect from one containers to another one by using name. We use this one, Docker run -d. So we have created this one and another one, two different containers created. And if you want to log in inside the web, the host DB now resolve the DB container. It's going to connect from one to another one by using the link commands. So why link is deprecated? So currently the link is not working. Why? Only works one directional and only between containers on the default bridge network. So this will work only one directional. That's why it is deprecated. It doesn't support automatic DNS resolution the way custom networks do. So custom networks will do DNS resolution, but here we can't do. And Docker's own documentation recommends migrating the user-defined networks. So that is the main recommendation by Docker own documentation itself. That's why we use Docker networking. But as per understanding purpose, we have to know about Docker link. That's why I have explained what is a Docker link. And mainly we use a Docker networking only. We don't use Docker link anyway. But Docker networking is very important as per our as a DevOps engineer. We should know very well. We use Docker networking and Docker volumes in the real time. Prefer this instead, create a custom network. We are going to use this one. So create custom network, we can use it. I think Docker volume I have not explained, right? Let me check it. Okay, Docker volume is missed. So Docker volume also very important. It is a very common requirement to persistent data in a Docker container beyond the lifetime of the container. So if you want more storage, then we use a Docker volume. However, the file system of a Docker container is deleted or removed when the container dies. So if the container is deleted, then it's going to delete the data as well. Solution: there are two different ways how Docker solve this problem. One is volumes, another one is bind directory and a host as a mode. So mainly volumes we use. Volumes aims to solve the problem by providing a way to store the data on the host file system separate from the containers file system so that the data can be persist even if the container is deleted or recreated. So if the container is deleted, the data will be deleted if you don't use the volumes. But if you use the volumes, the data will be present, it will be stored. So container memory will be there, volume like we are going to use the bit mount and we use a memory TMPFS where we use in the Linux, same as like that. Volumes can be created and managed using Docker volume command. You can create a new volume using the following command. So you can create volumes by using this particular Docker volume. So let me go here, Docker volume. So you can see local, volume name and driver local. These are the present Docker volumes. And if you want to create a new volume, then you can use Docker volume create. Oh, sorry, DevOps. So now if you check it, volume ls, the new volume is created. So once the volume is created, you can mount it to container using -v or mount option when running the container docker run command. So you can use docker run -it. So for example, ls docker ps. So now I will delete this container, docker rm-f docker ps docker images. So this particular image flash demo or node user I'll use. So docker run -it, then we have to use the -v with the volume name. So -v volume name is docker volume slash data. Then we have to use the image name. Image name I'm going to use node user /bin/bash. Okay, it is throwing some error internal modules. So docker run is I'm running the application. It is listening on 301. 1 second. Docker rm hyphen. So this when you run this particular command, it will mount the volume. That is the volume name, whatever you have given on data directory in the container. So it's going to create a data as a container directory, and all the data will be in that particular data as a home directory. Any data returns to the slash data directory inside the container. It will be persisted to the into the volume on the host file system. So inside the data directory, we have to write any data, then it will consider as a volume, that is whatever volume we have created. And if you want to check Docker PS, so if I want to check the data about this particular container, for example, you want to know about the volume, then we run the command docker inspect the container name you can use or container ID. So if you check here, it will be present what is the volume which we have used. See Docker volume. So it should be present here about uh, which which volume we have used. It will be mentioned here. I think somewhere. So status existed, everything will be display here. When we use a inspect, then we can get to know about the details. Okay. So Docker volume. eh, Okay, I have given as a Docker volume here instead of while creating also we can mention, but I have given wrong one. That's why it is taken. So now it is added with a DevOps volume. Like that we can create it. So we can check it by using a Docker inspect command. Next, bind a directory and host mount. So if you want to bind a directory on the hosted mount, then you can use it by docker run -it, the host path, then container path, then image name, then it will be like bash, whatever we are using sh or bin bash. So using this way, user can mount a directory from the host file system into a container. So bind mounts have the same behavior as volumes, but are the specified using a host path instead of a volume name. Instead of volume name, this is going to set the host path, but mainly we use the Docker volumes only. The main difference between volumes and bind directory is volumes are managed, created, mounted, and deleted using Docker API. However, the volumes are more flexible than bind mounts. That's why we suggest to use Docker volumes as they can be managed and backed up separately from the host file system and can be moved between containers and hosts. Next is bind directory. That is a host as a mount are appropriate for simple use cases when you need to mount a directory from the host file system into a container. So if you want to all the data into a system, host file system into a container, then we use a bind directory. While volumes are better suited for more complex use cases, but where you need more control over the data, then we use the bind directories. But other than that, when you want to make it as a flexible, then we use Docker volumes. That's it about Docker. So we have discussed all the topics which required as a DevOps engineer from the starting basics to advanced level. When you think about the basic, it will be like Docker installation, understanding, then architecture, Docker Hub, creating Docker image, Docker file, and Docker container commands, removing base image. These and all basics till pushing a Docker image into Docker Hub. And these are very advanced level which you should know and also very important. That is Docker events, networking, then Docker volumes. One second. Next is Docker volumes. So Docker volumes also very important, as we should know. Volumes. Okay, that's it about Docker. In the next class, we are going to start with the Jenkins. That is very important and also very interesting. We should learn as a DevOps engineer. We should always know about CI/CD. So we'll discuss in the next class. Thank you.